away. Okay. Now, if you went and got an engineering degree, mechanical engineering degree, then they would expect you to know how to calculate how many tons of CFM you're going to have pushed to cool that entire building or whatever. Now, and it's different. Some places, like if you look at the dorms, they have AC units for different pods down there or whatever that push it in from the outside. So, and if you have like rental properties, let's say I got a house and I have a rental upstairs and a rental downstairs. Well, if I'm going to make them pay the utilities, I have to split it, right? I'd have to have an AC unit for the first floor and an AC unit for the second floor. What we're doing, since this is all one building, we're going to put it up on the roof. We're going to pick a bigger unit, all right? But we're going to have it cool the entire building from that one unit. But there's a lot of calculations involved. And all I can tell you is this. It will not be expected for anybody coming out of here to know how to calculate that stuff. Now, if you work with a mechanical engineer long enough, he may show you. He may say, listen, you're doing so good on all the drawings and everything like that. How about if you get into a little bit more of the guts of it, and I'll show you. So, and we've seen that happen to students where they go out and they start working, but then they see they can take a little bit more responsibility on. So on smaller buildings, maybe they'll let them do some of the calculations and stuff like that and then check them. It always has to be checked off by a certified mechanical engineer. He has to sign off on it on the drawings. All right, but he may say, here, you do it, I'll check it, you know, and get you kind of working in that type of realm. All right. But what I determined is, in order for us to cool all 3 floors, we're going to need a 15 to 25 ton unit. So we want to go under mechanical, MEP, air side components, air conditioners. All right. And that gives you all your, now we're looking for a rooftop unit, 15 to 25 ton with a bottom return. There it is right there, 15 to 25 ton with the bottom return. Now, if you look at this little picture over here that it brings up when you click on it, the supply duct and the return duct, you can see in this one, they're on the bottom of the unit. So here's your supply duct with the X, here's your return duct. If we click on the one with the side return, see, your supply duct is still on the bottom, but when it returns air back to this, it's going to come up through on the roof, through a duct, and then go in the side. I like having both of them on the bottom because then the weather can't get to them. You know, if you got a duct that's coming up and going in the side, you may have water leaking in there and stuff like that when you get heavy snow or rain or whatever, okay? Having them on the bottom is probably a better way to go. So we're going to pick that one and just hit open. And what it'll do is it'll put it over here in your list now. You'll see. And it gives you different tonnage for that particular unit. In other words, you can go all the way from 15 to 25. Now, ironically, we're going to use the small one. 15 tons should do it for us. Okay. People go, well, why didn't you put in a 10 to 15 ton or something like that? Here's why. And I'm going to try to explain this to you, and I hope you understand it. Sometimes a building is built and then they want to add on to that building, or they want to go up another floor on that building. So when they built the structure, they built it to hold another floor, even though the budget didn't allocate for another floor. They made sure that the beams were of the size that it could hold another floor, so on and so forth. You want to make sure that that air conditioning unit can also be kept and transferred. So if I'm saying right now we're on the 15 ton, this one's capable of pushing up to 25 ton. So we could add another floor, no problem. Just take the unit, move it up, run your plenum back down, you're good to go. Connect it into the existing one. So sometimes it's better to oversize stuff with looking at the future being maybe an expansion type thing. All right, so that's why I went with the one that's 15 ton, but it can go up to 25 ton. Okay, so 15 tons the one we're going to pick, doesn't matter. All right, now we want to put this on our roof. So you should have a view called TOM, top of masonry. Double click on that view. And what you should see is a roof plan. Okay. Now, what's the issue we have here? If I go to put this on the roof right now, what would you say is a problem? Can't see anything. I don't know where I'm putting it. Am I over top of those? Now, I know you guys say, okay, well, we could guess it's going to go right in here somewhere, you know, if you want to go straight down. Yeah. But here's what you can do that's really nice. You can use an underlay. Watch this. So if I scroll down in the properties, you're going to get a category that's going to be called underlay. And right now it's set to none. But this is like referencing a different level to see what's on that level. So if I said, okay, let's go to level 3. Okay, move over, look, nothing comes up yet. But look at the orientation. They're looking down. So if you go to the middle of the room and you look down on level 3, you're not going to see the HVAC, are you? We have to look up. So change look down to look up and then move over and look what happens. Now you got a pretty good idea where you're going to put that unit, okay? Because you can see your ductwork. Makes sense. We're going to turn this back off after we're done. Okay? I just wanted to show you how you could kind of get the idea of where you need to put the unit based on where your ductwork is. Okay. So we're going to get ready to place this unit. Now, here's something else to think about. Do you want the unit sitting right down on the roof? Or do you want it to be a little bit up off the roof? I've seen them done both ways, and here's what I'm going to tell you. If they ever have to replace that whole entire unit and it's on the roof and it's sealed, very tough to do. If you put it about a foot up off the roof and you put supports around it, it also makes it easier for them to get in there if they need to disconnect that plenum that comes down out of there for some reason. So we're going to put ours about a foot up. We're going to do about a foot offset. All right. So here we go. Watch. I'm going to place mine. Go and click on mechanical equipment. Pick the 15 ton. Move over onto your screen. Now, if you scroll in this properties thing,